Hi, I'm Julia, the chemistry tutor. Welcome to my website. Today I'm going to talk about polyatomic ion nomenclature. Okay, so nomenclature is just naming. So it's how to name your polyatomic ions. And polyatomic ions period, are going to be extremely important for the entirety of your chemistry experience. If you don't memorize and know your polyatomic ions, you likely will not pass your chemistry classes. All right, so let's get started. Okay, polyatomic ion nomenclature. Okay, so poly means more than one. Atomic means type of atom. Ion means that it has a charge. Okay, most of your polyatomic ions have negative charges. There are two of them you'll need to know that have positive charges, but most of them are negatively charged. Okay, and nomenclature is just naming. Okay, so naming ions that are charged that have more than one type of atom. And typically they have oxygens. Usually it's oxygen and one other type of atom. There's one of them, or I think one of them, that doesn't have any oxygens, but otherwise it's oxygen and at least one other type of atom. Okay, so the first thing you're going to do is you're going to memorize this saying right here: Nick the camel ate a clam for supper in Phoenix. Okay. And we're going to use the first letter of each of those words that I have highlighted in red and underlined. Okay. And our rules for this is that our consonants are going to equal our number of oxygens in the polyatomic ion. Your vowels are going to equal your number of negative charge in the polyatomic ion. Okay. So when we have nitrogen, Nick has three consonants, so three oxygens, and one vowel, so a one negative charge. That is your nitrate. Okay. And the word eight is in this saying because these are all the ones that end in eight. Okay. The last word of the word is eight. Okay. So then carbon, camel has three consonants, so three oxygens, two vowels, so a negative two charge. That is your carbonate. Okay. You just take your root, like nitrogen is nitra, and add eight. Carbonate, we say carbon, the whole word, and add eight. Okay. So chlorine, so carbon took the C, so we have to use both the C and L from clam. So that's the chlorine. And clam has three consonants, so three oxygens, one vowel, so one negative charge. That is your chlorate. Okay. S for sulfur. Supper has four consonants, so four oxygens, two vowels, so a two negative charge. That is your sulfate. Okay. And then P for phosphorus. Phoenix has four consonants, so four oxygens, three vowels, so a negative three charge. That is your phosphate. Okay. So memorizing that saying right there, you memorize the basic, the parent ions. I call them the parent ions, are the ones that end in the word eight. Okay, so your parent ions all end in eight, and this is a saying for you to memorize a few of them. Okay, and then we're going to take that concept and we're going to apply it to a lot of other chemicals on the periodic table. Okay, so now down along this side of my chart here, I have highlighted in blue the ones that come from the Nick the Camel saying. I have my Nick Camel ate a clam for supper in Phoenix. Okay, so those are all highlighted in blue. Things that you need to memorize are going to be highlighted in blue. Okay, then you're going to apply those things to other ions. Okay, so one of the things I want to point out here is your chlorate from clam. Okay, three oxygens and a negative one charge. Okay, your halogens, group 7 on the periodic table. Your halogens, well, that whole group is exactly the same. So your chlorine, your bromine, your iodine, and your fluorine, all your halogens, we know from clam that chlorate has 3 oxygens and a 1 negative charge. That means bromate, 3 oxygens and a negative 1. Iodate, 3 oxygens and a negative 1. Fluorate, 3 oxygens and a negative 1. Okay? So in a group going down the periodic table, they tend to be exactly the same. They like the same number of oxygens and the same charge. Okay? So if you know chlorate from clam, you also know bromate, iodate, and fluorate. Okay? So now we're going to apply the same rules from sulfate here to selenate. Selenate is right underneath sulfate on the periodic table, same group. So if sulfate has 4 oxygens from supper, 4 oxygens and a negative 2, selenate also has 4 oxygens and a negative 2. Okay? And we're going to apply the same rule here to phosphate and arsenate. Arsenate is right underneath phosphate on the periodic table, same group. From the word phoenix, phosphate has 4 oxygens and a negative 3. So arsenate also has 4 oxygens and a negative 3. Okay, so what you'll notice is that nitrogen and phosphorus are in the same group on the periodic table, okay? But they are not the same for their ions. Nitrate has only 3 oxygens and a negative 1, whereas phosphate has 4 oxygens and a negative 3, okay? So nitrogen is a rule breaker. The ones that are across the top on the periodic table, the carbon and the nitrogen, those don't really follow trends in their groups, okay? So the halogens, group 7, follows trends, and below nitrogen, phosphorus and arsenic follow the trend, and below oxygens, sulfur and selenium follow the trend, okay? But nitrogen does not follow in that same trend as phosphorus, even though they're in the same group, okay? Okay, so now I'm going to start applying these rules across the top here, okay? The rules written in blue across the top here. So our first rule is if we have 1 less oxygen, our 8 becomes an ite, okay? So you see nitrate has 3 oxygens, 1 less oxygen, so 2 oxygens, it becomes an ite. Nitrate to nitrite, 1 less oxygen. And you'll notice your charge stayed the same. So you know your charge from the Nick the Camel saying it stays the same all the way through, okay? Not over here, but don't worry about those yet, okay? So now carbonate has 3 oxygens, lose 1 oxygen, so carbonite has 2 oxygens, and your charge stayed the same. Chlorate has 3, chlorite has 2, and your charge stayed the same. All the way down. Bromate has 3, bromite has 2. Iodate 3, iodite 2. Fluorate 3, fluorite 2. Sulfate 4, sulfite 3. Okay? All the way down. All of your ites have 1 less oxygen than the 8. Okay? Then we move to our second rule here, which is if you have 2 less oxygens, you become a hypoite. Because in science, hypo means really low. Like hypothermia, really low body temperature. So if I'm low on oxygens, if I lose 1, I'm low and I become an ite. But if I lose 2, now I'm really low on oxygens and I'm a hypoite. Okay? So I had 3 on my 8 to start with. I lose 1, I become an ite. I lose 2, I become a hypoite. And notice your charge stays the same. Carbonate had 3, lose 1, become a carbonite, lose another 1, hypocarbonite, okay? All the way down. Chlorate has 3, chlorite has 2, hypochlorite 1. So you're gradually losing 1 oxygen at a time, going from 8 to ite to hypoite, okay? Same all the way down. Bromate 3, bromite 2, hypobromite 1. Iodate 3, iodite 2, hypoiodite 1. Okay, down here, phosphate has 4, phosphite has 3, hypophosphite has 2. Okay, so gradually just losing 1 oxygen at a time, going from your 8 to your ite to your hypoite. Okay, so our third rule here is 1 more oxygen, you become a per-ate. Okay, because per means more in chemistry. So if you have 1 more oxygen, you're a perate. Okay, so nitrate had 3. Now I have one more. I'm still nitrate, but now I'm even more. I'm per-nitrate. And you'll notice your charge stayed the same. Carbonate has 3. Percarbonate has one more. Okay, charge stayed the same. All the way down. Chlorate 3, perchlorate 4. Bromate 3, perbromate 4. Down here, I've got sulfate has 4, so persulfate has 5. Phosphate has 4, so perphosphate has 5, okay? And you notice your charges didn't change. So you go from your 8, lose an oxygen, become an ite, lose 2 oxygens, become a hypoite. Gain an oxygen, you're a perate, okay? And then over here, okay, these are not polyatomic ions, they're monoatomic. They only have one type of atom there. But I put them on here just because they follow a trend. If you have no oxygens at all, okay, your anion is an ide, okay? So what I want you to notice is these two, your charges changed, okay? The charge does not stay the same on nitrogen and carbon, okay? Nitrogen and carbon do different things, okay? So those are my previous video where I talked about the periodic table and how to determine what your charge is from the periodic table. Okay, that's for monoatomic ions. And nitrogen on the periodic table gains 3 electrons to be perfect like a noble gas, so he has a -3 charge. Carbon will gain 4, so he has a -4 charge, okay? The rest of them actually follow their charges on the periodic table. On the periodic table, all of your halogens are a -1, and all of your halogen ions are a -1. Your sulfide on the periodic table is a -2, sorry. All of your sulfurs are a -2, same with selenium. Phosphide on the periodic table is a -3. All of your ions with oxygens with phosphorus, -3, same with arsenic. Arsenide on the periodic table, -3. All of his ions are -3. Okay? So most of your ions, you can get your charge off of the periodic table. But nitrogen and carbon, absolutely not. Those break the rules when they have oxygens with them. Okay? All right. Okay, now we're going to talk about when we add hydrogens to ions. What happens when we add a hydrogen to it? Okay? So when you add a hydrogen, okay, hydrogen on your periodic table has a +1 charge, okay? So anytime you're adding a hydrogen, you are adding a 1 positive charge, okay? So here on nitrate, if I added a hydrogen to nitrate, nitrate being the -1, hydrogen being the +1, that equals 0. That no longer has a charge. That is not an ion, okay? So we're not going to name ions that have a hydrogen added to a -1 charge because that's no longer an ion. That's actually an acid, and we'll talk about naming those later on, okay? So if it's got a -1 charge on the ion, you're not going to add a hydrogen to it and call it an ion, okay? So that's why here I don't have anything in there because we're not going to add a hydrogen to those, okay? So, but here for carbonate, if I take carbonate, which is a -2, and I add a hydrogen to them, which is a +1, that whole thing now is -1, okay? And we call that hydrogen carbonate. So it's just carbonate with a hydrogen added to it. Hydrogen carbonate, a hydrogen and a +1 added to it, okay? Now there is a common name for this one, and that is bicarbonate, okay? Bi in chemistry does not mean 2. Di means 2. Bi means you added 1 hydrogen and the compound still has a charge, okay? So that's probably the only one that you need to memorize as a bicarbonate. You've heard of it. Sodium bicarbonate is baking soda. Okay, so that's the common name for hydrogen carbonate is bicarbonate. Okay, but over here, it's the same process. If you add a hydrogen to the ite, So your carbonate had 3 oxygens, carbonite has 2, add a hydrogen and a positive charge. So you went from a -2 to a -1, hydrogen carbonite. Okay, so you just add a hydrogen and a +1 and put hydrogen in front of the ion name. Okay, so here on your halogens, they're all -1, so we're not going to do it. Okay. So for your sulfate here, sulfate, if I add 1 hydrogen and a +1 charge, hydrogen sulfate. Sulfite, same thing, add hydrogen and a positive charge, hydrogen sulfite. Same thing with your selenate, hydrogen and a positive charge, hydrogen selenate, hydrogen and a positive charge to selenite, hydrogen selenite. Okay, same process with phosphate. Add a hydrogen and a +1 to your phosphate. So you're left with a -2, hydrogen phosphate. Add a hydrogen and a +1 to phosphite, hydrogen phosphite. Same thing with arsenate and arsenite. Hydrogen arsenate, hydrogen arsenite. Drop the chart, add a 1 positive and a hydrogen, put hydrogen in front of the name. Okay, so now the last rule here is if you add 2 hydrogens. Okay, so if you're adding 2 hydrogens, you're adding 2 positive charges. Okay, 2 hydrogens, 2 positive charges. Okay, so we ended here on the hydrogen carbonate with the 1 negative. We can't add another hydrogen and still have a charge, so we're not going to do that. Same thing here with your hydrogen sulfate and hydrogen sulfite. You can't add another hydrogen and still have a charge, so we're not going to do it. Same thing with the hydrogen selenate and hydrogen selenite. You can't add another hydrogen and still have a charge. Okay? But your phosphate and your arsenate, your hydrogen phosphate and your hydrogen arsenate, okay? You ended those with a -2. So you can still add 1 more hydrogen and have a charge, okay? So if I took my phosphate with a -3 and I added 2 hydrogens, I'm adding 2 positives, so that whole thing equals the -1. So di means 2. So now we just say dihydrogen. I added 2 hydrogens and 2 positive charges to my phosphate. Same thing with arsenate. Arsenate has a 3 negative. If you add 2 hydrogens and 2 positive charges, you have a -1. Dihydrogen arsenate. Okay, you can apply the same rule to the phosphite and arsenite. Add a 2 hydrogens, dihydrogen phosphite. Add 2 hydrogens, dihydrogen arsenite. I just didn't have enough room to put them on my chart. Okay, so we're just following those rules. So if you know your Nick the Camel saying, so you know all those along the side there highlighted in blue from Nick the Camel, and you know the concept of the same groups follow the same trend, you know all of those on the left. If you know all of the rules across the top and can apply those, you know all of these ions. You don't need to memorize anything that's not highlighted. Okay, so a lot less memorizing if you understand the saying and memorize your parent ions from the saying and know those rules across the top and apply them. You don't need to memorize any of those other ions. Okay, so there's a few that you do just need to memorize. Okay, they don't lose oxygens, they don't gain oxygens, you don't add hydrogens to them. They're just ions, polyatomic ions you need to memorize. Okay, so acetate, this guy right here, okay? A lot of students think that's going to be the hardest one to memorize, but most students actually memorize it pretty easily because it's got so much stuff in it. Okay, I've seen students memorize that it's CHO 2, 3, 2, 1. CHO 2, 3, 2, 1. Okay, your permanganate has 4 oxygens and a -1. He's very much like your per halogens, your perfluorate, per iodate, per bromate. They all have 4 oxygens and a -1. Okay, you just got to memorize it. Your oxalate, okay. You probably haven't done Lewis dot structures yet, but if we drew the structure for this, it looks like this, and I think it kind of looks like a box. So that's my carboxylate ion. Okay, it looks kind of like a little weird box there, my carbox. Okay, so that's how I memorized that one. Your chromate is a chromium. He likes to have 4 bonds, so he gets 4 oxygens around him, and he just has a -2 charge. You just got to memorize that he's a -2. Okay, your dichromate here. Dichromate makes sense that you would add another chromium. Okay, so I added another chromium. But now if I'm adding oxygens, I can only add 3 more oxygens. So you've got 2 chromiums and 7 oxygens, and he still is the -2, just like chromate. Okay, so that might help you memorize that. Hydroxide, so these two right here only have 2 atoms in them. Okay, hydroxide, a hydrogen and an oxygen, hydroxide. And we know oxygen's -2, hydrogen's +1, so that whole thing is a -1. So hydroxide with a -1 charge. Okay, cyanide, I remember because it's got a C and an N right there in the name, cyanide. And you just need to remember that it's a -1 charge. Okay? So those are just memorizers. You just got to memorize those. They don't have a saying. They don't lose and gain oxygens. They don't follow rules. You just got to memorize those guys. Okay, and then these two here are your 2 polyatomic ions that have positive charge. Okay, ammonia is an H3. If he gains a hydrogen and a positive charge, he becomes ammonium. Water is H2O. If water gains a hydrogen and a +1 charge, that is hydronium. Okay, you're going to work with the hydronium ion a lot when you work with acids and bases, but you're probably not going to do a whole lot with it until then.